All right, welcome back to class today. We'll be looking at how to graph linear equations, and we have what we call slope, intercept, and y-intercept and x-intercept. But today, what we'll be looking at the first method of graphing linear equation will be using the intercept method. And let's first of all write y the equation in linear intercept form. That means you can see it y equals to mx plus b. This is when you see the equation of a straight line when its intercept, intercept slope form. So in this case, m is called the slope or gradient, yb is called the y-intercept. And what do we mean by y-intercept? Y-intercept, it means, if this is our graph, the points are through which the graph goes through this y-axis. This is what we call y-axis, and this part is called x-axis. So this point here is the y-intercept, so we call it y-intercept, and this point here is called x-intercept. So if we can find both y-intercept and the x-intercept of the equation, we can easily plot a linear equation with that. So let's say, for example, so we want to plot this equation example now. Let's say we have y equals to 3x minus 2. For example, y equals to 3x minus 2. In this case, using a formula where we say y equals to mx plus b, if we compare both of them, you discover that m equals to 3 and b, which is the y-intercept, equals to minus 2. So it means that on the graph, yes, on the y-coordinates, the y-intercept is on minus 2. That means the line goes through y-axis on minus 2. So now let's get our intercept now. For our y-intercept is at the point where the line goes through y-axis, and at that point x is going to be 0. So if at the y-intercept x is 0, what that means is that we're going to do so we're going to substitute 0 for x in the equation. Y becomes 3 into bracket 0 minus 2, and this is going to be 0. That's y equals to minus 2. So for the x-intercept now, that's going to be where we see y going to, that means at that point 2, that's why it goes through the x-axis, and at that point y is 0. So y equals to 0. So what we have is going to be 0 equals to, from the equation, 3x minus 2, and that will become 3x equals to 2. If we divide both side by 3, we're going to have roughly 0.7. That's 0.666. But for our goal, so now let's try to draw this now on our sketch this graph now. So if this is our y-axis, this is y-axis, and this is x-axis. So this is positive y-axis, this is the negative y-axis, this is the positive x-axis, and this is the negative x-axis. So at the point now, let's say when x is 0, what is y? Y is 2. So that means that the coordinates for this point on the y coordinate is 0 comma minus 2. We will write it in this form: x first, the position of x first, then y next. Then in this case also, x first, that's 0.7, and y equals to 0, 0. When x is 0.7, y equals to 0. So that means we know that this is our y is negative 2. That's where we're at. So this is negative 2 here. And on our x's, this is 1 and this is 2. So when x is 0, y is negative 2. So when x is 0, let me use another pen color. So when x is 0, so y is negative 2. We move down y, and that's the point here. So that's the point where y is negative 2. And when y is 0, x is 0.7. So let's say 0.7 around this point. So we can now draw a straight line to show that out. So this is our straight line graph for this equation. So let's take another example. For instance, let's do example 2. So let's say 2y is equals to 7x minus 6. In cases like this, first of all, we need to make it also to be in this form, y equals to mx plus b. And what we need to do is to make y subject of formula. That means dividing all through by 2, because that's the coefficient of y in this case. And so when we do that now, we're going to have 2 divided by 2 divided by 2. And that's going to give us y equals to 7 over 2x minus 3. So when we have this, yes, now it's in the form we want. So m equals to 7 over 2, which is still 3.5. And our b is negative 3. Okay, let me use something like positive now. We've done negative before. So positive 3. So now what we need to do is to find the y-intercept. Y-intercept, you remember what we said? That x is going to be 0. X is going to be 0. So that means y equals to 7 over 2 to 0 minus 3. This is all going to be 0. That is y equals to minus 3. And when we're looking for x-intercepts now, x-intercepts, that when y also be 0. So if we put this equation back now, so we have what? That was 0, substitute that we have 7 over 2x plus 3. I said we change the sign, right? Sorry, plus 3. Keep writing the sign. I said the sign has been changed. So let's use a positive value for this. So we have y equals to plus 3 equals to 0. So when this go to the other side, it's going to have 7 over 2x minus 3. So what do we do? If you multiply both sides by the inverse of 7 over 2, that will be 2 over 7 times 7 over 2x equals to minus 3 times 2 over 7. And this is going to give us x is minus 6 over 7. And minus 6 over 7, let's check that out. 6 divided by 7 is, that's also 0.85. Let's approximate to 0.9. So that means on the x-intercept, that is when y is equal to 0, x is 0 minus 0.9. And on the y-intercept, when x is 0, y is 3. So we can plot this on our graph, on our line now. So let's say this is our y-axis, and this is our x. Sorry about my line. Okay. This is our x-axis, and this is our y-axis. So when x is 0, y is plus 3. So we have 1, 2, 3. So when x is 0, y is plus 3. On the point where x is 0 is at the origin. Both x and y are 0 at the origin. So when x is 0, just move up to y 3. So that point is this place here. And the next one is when y is 0, x is 0.9. So that's still on the positive side. This is 1. This is 2. 0.9 will be somewhere. When y is 0, x will be 0.9 at this point. So let me show that with this blue pen. So we can now do what? And draw our line together. So I'm trying to use, yes, this is it. So this is how to draw a graph of linear equations using intercepts method. So that's all for today. Thank you. See you next class. Bye.